Welcome back for another video that will show a proof of one of the properties of hyperbolic functions. Again, we've already defined the 6 hyperbolic functions given here. We also discussed how, while even though these are exponential functions, they share similar properties to trig functions, some of which we can see here on this screen, but there's also several other properties given here on this screen. In this video, we're going to be proving this identity here, where hyperbolic tangent squared x plus hyperbolic secant squared x is equal to positive 1. So let's go ahead and get started. I want to show a pretty detailed proof, so we're going to write each of these hyperbolic functions in exponential form, square them, and then show the left side is equal to positive 1. Since hyperbolic tangent x is equal to hyperbolic sine x, since hyperbolic tangent x is equal to hyperbolic sine x divided by hyperbolic cosine x, we're going to write hyperbolic tangent squared x as e to the x minus e to the negative x divided by 2. This is equal to hyperbolic sine x divided by hyperbolic cosine x, which is equal to e to the x plus e to the negative x divided by 2. But since we have hyperbolic tangent squared x, this is actually all being squared, plus hyperbolic secant squared x, where the hyperbolic secant function is equal to the reciprocal of the hyperbolic cosine function. So we can write this as 2 divided by e to the x plus e to the negative x squared. Again, this is the hyperbolic secant function, which is the reciprocal of the hyperbolic cosine function. We want to show that this is equal to positive 1. Let's start by simplifying inside the parentheses here. We can actually simplify out the denominators of 2 if we multiply the numerator by 2 and the denominator by 2, which is just multiplying by 2 over 2, which is equal to 1. But when multiplying the numerator by 2, this 2 and this 2 simplify to 1, and when multiplying the denominator by 2, this 2 and this 2 simplify to 1, which means this fraction now has a numerator that consists of 2 factors of e to the x minus e to the negative x, and a denominator that contains 2 factors of e to the x plus e to the negative x. And now for the second fraction, we can go ahead and square 2. That would be 4. Then if we square the denominator, we would have 2 factors of e to the x plus e to the negative x. At this point, notice how we do have a common denominator, which means we can combine these two fractions. The fraction would have a common denominator of e to the x plus e to the negative x squared, and the numerator would consist of 2 factors of e to the x minus e to the negative x plus 4. And now for the next step, we'll go ahead and multiply these two binomials, and then we'll combine like terms. Remember, when multiplying and the bases are the same, we add the exponents. So e to the x times e to the x would be e to the 2x, since x plus x is equal to 2x. Next we have e to the x times negative e to the negative x, which will be minus e to the x plus negative x, which would be e to the 0. And then we have negative e to the negative x times e to the x, which again would be minus e to the 0. Remember, these are both equal to 1, since anything to the 0 power is equal to 1. And then finally we have negative e to the negative x times negative e to the negative x, which would be positive or plus e to the negative 2x. And we still have plus 4 equals 1. Let's go ahead and continue this on the next slide. Well, since e to the 0 is equal to 1, this is minus 1 minus 1, or negative 2. Negative 2 plus 4 is equal to positive 2. So we can write this as e to the 2x plus 2 plus e to the negative 2x all over our denominator. Now at this point it gets a little tricky, but if we keep in mind we want to show this is equal to positive 1, the only way this will equal 1 is if this numerator is equal to the denominator, which means if this factors, it'll factor into 2 equal factors. So let's go ahead and try it. The 2 equal factors of e to the 2x would be e to the x and e to the x. The 2 equal factors of e to the negative 2x would be e to the negative x and e to the negative x. And because the middle term is positive, these would both need to be plus. Now to check to make sure this works, we know that the inner product and outer product must have a sum of positive 2. So let's go ahead and check that. The outer product would be e to the power of x plus negative x, which would be e to the 0. And the inner product would be e to the 0 as well. And since e to the 0 is equal to 1, this is just 1 plus 1, which is equal to 2, which is our middle term. So this does factor into two equal factors. And notice how these factors are the same factors in the denominator. So this will equal positive 1. Let's go ahead and write this as e to the x plus e to the negative x squared all over e to the x plus e to the negative x squared equals 1. And now we can easily see the left side is equal to 1, and of course the right side is equal to 1, and therefore we have our proof. Okay, I hope you found this explanation helpful. We'll take a look at another proof in the next video.